do you guys think? Does anyone, I heard a couple of 3 to 6s. Do we agree with that answer? How do I know that? Okay, that's great. That's one way to look at it. Since the slope is positive during that interval, or yeah, see like, or if it's position, like your position's becoming more positive, and you're adding some position. You're adding some plus. Does that make sense, Estella? Okay. All right, back to velocity graph. We're looking at a velocity graph. When is this thing moving to the left? If this is a velocity graph, when is our little particle moving to the left? Be careful with that 2 to 3 little time frame. Be careful. When am I moving to the left? Why is it not 1 to 2 and 3 to 5? And it's your first guess, 1 to 5. And why is that correct? Yes?
Because even though there's a line there that doesn't mean velocity is 0, it means it's constantly negative.
Yes, you're not speeding up or slowing down. You put it in cruise control. When I hit mile marker 8, I put on the cruise control. Does that make sense, you guys? That's what this means in a velocity graph. You're still going, whatever, say this is like negative 10 or something, you're still going, 10 feet per second to the left. Does that make sense, you guys? You just decided not to speed up or slow down for this second. Does that make sense, Jessica? Okay. All right, if this is a position graph, when are you moving to the left? If this is a position graph, when are you moving to the left? I heard 0 to 1 and I heard a 0 to 2 for that first section. Who wants to back up either case? If this is a position graph, look at my hands. You guys see those big sausage links right here? What is it, breakfast time, Mr. Remus? Anyway, go ahead. Yeah, the rate on that line segment, it's a line. So if you did take the derivative, it would be negative. Does that make sense, you guys? It doesn't stop at 1. That's the difference between like the position of light. If this is a position graph, you are going left this entire time because your position is getting less. And here. Or it's when the rate of change or the slope of this curve would be negative there. Does that make sense, you guys? Yeah? Okay. Alright, so if this is a velocity graph, you guys ready? Okay, if this is a velocity graph, when is the velocity equal to 0? One, 5, and 7 through 9. How do you know that? Okay, I'll buy that. What if it's a position graph?
2 to 4.
So 2 to 3, you guys think? What about at 2? What do you guys think? If you're looking at a position graph, and I want to know when the velocity is equal to 0, what is velocity in terms of position? What is it? Of the what did you say?
Is the velocity is the derivative of the position?
Yeah. Can you take the derivative at 2?
It becomes 0.
Hmm?
It becomes 0.
What?
The derivative of 2 becomes 0.
No, at 2. At t equals 2. Can you take the derivative there? What do you guys think? Okay, well let's look at differentiability at a point. First thing you have to check for differentiability at a point is it's continuous. Is this continuous at 2?
Yes.
Yeah, limit from the left equals limit from the right, whatever that y value is. Next thing you check is the derivative from the left and from the right. And it is a corner. You see that? So this is kind of a goofy one in terms of if our velocity graph were fine, but this thing has a lot of pickles, and if it's a position graph. Does that make sense, you guys? Yeah? Now between 2 and 3 is a whole bunch of points, so there's always points where they are, but at those corners you just have to be careful. Okay, was that fun or no? Did we like that? Okay, good. Alright. If this is a velocity graph, when is the function slowing down?
4 to 5, 6 to 7.
So, this thing is slowing down. I heard a couple different things now. What's the first one? 0 to 1? Why do we think 0 to 1?
Approaching 0.
It's approaching the x-axis. Does that make sense? Or, that's a positive value and its slope is negative. Different signs. Does that make sense, you guys? Where else did you say? Okay, 3 to 5. What's happening? Katie, as Katie would say, is you're approaching the x-axis. As you go to the right, as time is moving on, you're approaching the x-axis, so you're slowing down. Or, signs are different. Here, your velocity is positive, and the derivative of that is going to be a positive, the velocity is negative, but if you take the derivative of that, it's going to be a positive value. So the acceleration is going to be positive, velocity is negative, different sign, you're slowing down. Does that make sense, you guys? How are we feeling with that? Okay. Anywhere else?
6 to 7.
And 6 to 7. Okay, great. So let me talk about one other thing. You had a big weird problem, that was the last problem in your notes. I want to talk about something related.